Hello, students, and welcome to our April 6th algebra lesson. We'll start with our do now. We're going to complete the chart about emotion management strategies, a nifty little activity. Our objective today will be to factor polynomials of a certain type, polynomials that are a difference of squares. So our essential questions are, what are the 3 steps to follow when factoring a difference of squares, and what is the difference of squares rule? For our assignment, we will complete the do now, the 2 work pages, the exit ticket, and if you are a distance learner, please submit your photos of your work on Teams. If you are in person, make sure to show me your work as I walk around the room. You do not need to take photos. That's for people who I can't see. So for homework, I would like you to do homework 6, which is factoring a difference of squares. And remember, stay the course. There are quadratics ahead, and quarter 4 is here. You're going to high school, and I look forward to you being very successful there, armed with good, strong algebra skills. Now, here's our do now. It's about emotion management strategies, and we want you to think about a school situation that could cause strong emotions. It could be you ran into someone and had a misunderstanding. Could be you got a test back that you didn't like, the grade, but let's write that right there. Just a sentence or 2. Then you're going to describe a negative decision that might be made as a result, and we've all made those. So let's be honest. If you have to make this up in your head, that's fine, or you could write a real situation. But after you do that, I want you to take that extra step. Now that you're backing away from the situation, you're not in the thick of the moment or the emotions, and I want you to offer an appropriate management strategy that might be had to turn that situation around, or at least to be better and kinder to yourself. So I look forward to your responses there. So today our topic is factoring a difference of squares. And this is one of the favorite algebra topics. It really is. We're going to start with a warm-up, and as we warm up, we're going to use FOIL, the FOIL method, another algebra favorite, our first outer inner last strategy to help us simplify these polynomials. So x times x is x squared. 4 times outer, we'll do the outer first. We want to keep with the FOIL strategy. Outer, x times negative 4 is negative 4x, then the inner, positive 4x, and then last, negative 4 times positive 4 is negative 16. We combine the center terms, we have positive 4x and negative 4x, and what we're left with is x squared minus 16. So let's do the next one. So first, 5m times 5m, that's 25m squared. Outer, 5m times negative 1, that's negative 5m. Inner, 5m times a positive 5m is positive 5m. And last, negative 1 times 5m, I'm sorry, negative 1 times positive 1 is negative 1. We combine the center terms, negative 5m plus 5m will equate to 0, so we're left with 2m squared minus 1. And in the third example, 2a times 2a is 4a squared. 3a times negative, or 3b, excuse me, times negative 3 outer, 2a times negative 3b. I'm going to erase some of these lines. Okay, we did the first, now the outer, and I'm going to make the lines thinner so that they aren't so thick. I think this will be, oh, here we go. Okay, outer, 2a times negative 3b, negative 6ab. Now inner, positive 3b times positive 2a, so that's a positive 6ab. And last, 3b times negative 3b is 9b squared, and that's a negative 9b squared. The center terms will cancel out again. So we have 4a squared minus 9b squared. Now, in all of these cases, the resulting difference of these polynomials, these binomials, is called a difference of squares. So when we multiplied x plus 4 by x minus 4, we ended up with a difference of squares. Get a highlighter here. When we multiplied 5m plus 1 by 5m minus 1, we have 2m squared minus 1, which is a difference of squares. When we multiplied 2a plus 3b by 2a minus 3b, we ended up again with a difference of squares, 4a squared minus 9b squared. So this, what we have here on the right side, this is our difference of squares. So how do we factor it? How do we go from here back to there? So we've gone from in this direction, but we want to go back again. So the first thing you need to do is to make sure that you have an actual difference of squares. So look how these are written: x plus 4, x minus 4. 5m plus 1, 5m minus 1. Okay, so you have actually a difference of squares. If you don't have that subtraction sign, you won't be able to square root both terms in order to get this result. So you make sure you have a difference of squares. That's the first rule. The second step, is to use the following rule. Now here's our rule: a squared minus b squared, okay? A squared minus b squared. Here we had x squared minus 16, which was a square of 4. We have 2m squared minus 1. 1 is a square of 1. We have 4a squared minus 9b squared. Both those terms are squares. So every term is a square. Okay, so we make sure we have a difference of squares. Now, to factor the difference of squares, we have a squared minus b squared equals a plus b multiplied by a minus b. And then you can just check your work by distributing. You can FOIL. You can use FOIL or just distribute in any order. Just make sure you don't do anything twice. And you should end up with your original problem. So let's try a few together, and then you'll try a few on your own. So we're asked to factor each difference of squares, and we're going to check our work by distributing. If a polynomial cannot be factored, we need to write prime. So a squared minus 4 would be, okay, we need two sets of parentheses, a plus 4, a minus 4. I'm sorry, 2. Can't believe I said 4. I meant to say 2. So a plus 2, a minus 2. Now watch what happens when we, so this is the answer, okay? But what we want to do is check by distributing. So first, a times a is a squared. Outer, a times negative 2 is negative 2a. Inner, positive 2 times a is positive 2a. And last, 2 times negative 2 is negative 4. The middle two terms will cancel each other out, and we end up with a squared minus 4, and our answer checks. So take the square root of the first term and the square root of the second term and put them in the parentheses. So what you'll end up with is two binomials. So we have, let's make our parentheses. So n squared is n times n, and we have our plus and our minus. 64 is 8 times 8. Now, if we FOIL that, we will end up back with n squared minus 64. So number 3, what's the square root of 81? Well, that would be 9 times 9. Put our plus and minus sign. The square root of x squared is x. Number 4, c squared minus 100. The square root of c squared is c. We put our plus or minus. And the square root of 100 is 10. And if you were to FOIL this, you would end up back with c squared minus 100. So try a few of these on your own. Let's see how you do. Now, did you try number 5? For number 5, we have k squared plus 25. But the problem is it's not a difference. It's not subtraction. Okay, so that means it is prime. Needs to be subtraction in the middle. So number 6, 1 is a square of 1. 1 times 1 is 1. So that's not very obvious, but very true. So we have 1 plus 1 minus, and 49y squared would be 7y. And that's our final answer. And number 7, we have 9b squared, so that would be 3b. And 100 is 10 times 10. So you got to have each term has to be a perfect square. So number 8, we have 25x squared minus 49, 2 perfect squares. So we're going to start out with 25 would be 5x times 5x gives us 25x squared. We put our plus and our minus, and then our 7, because 7 times 7 is 49. Number 9, 16a squared would be 4a times 4a. And 121 is 11 times 11. So I told you, memorize those squares up to 12. Number 10, we have x squared minus 81y squared, both perfect squares. So we have x plus x minus 9y, 9y. And number 11, we have a perfect square in 4h. And then we have a perfect square minus 25, or h squared, excuse me, and a perfect square minus 25g squared. So 2h plus 2h minus 5g, 5g. And number 12, 64u squared is 8u times 8u. So we'll have 8u plus, and we have v squared plus v, 8u minus v. Let's move on to the next page. Try number 13 through 20, and then let's come back and see how you did. So I'm going to change the color for 13 through 20. So x squared y squared minus 1 is xy times xy, and that would be plus 1, xy minus 1, and that's our final answer. Number 14, 81n4 minus 25. Yes, we have a difference of squares, so we would have 9n squared, okay? Because when we multiply exponential terms, we add the exponents. When we divide exponential terms, we subtract the exponents. So it would be 9n squared minus 5, or I'm sorry, we'll start with plus 5, and then 9n squared minus 5. We usually put the plus term first. Now number 15, 4c squared, we could have a plus or minus and start with 2c. However, we've got a problem with this 5d squared. 5 is not a perfect square. So this expression is prime. Number 16, we have 49m4 minus 16, so it is a difference of squares. That would be 7m to the second power plus 4, 7m to the second power minus 4. Number 17. Remember, when we multiply, we add exponents. When we divide, we subtract exponents. So this is a square, and this is a square, perfect square. So we have k to the third plus 4 and k to the third minus 4. And then number 18, 4p to the fourth minus 25 would be 2p squared minus 5 plus 5, and 2p squared minus 5. And number 19, 121r6 minus 1 would be 11r to the third plus 1 times 11r to the third minus 1. And remember, you can use FOIL, distribute these two binomials, and you will be back at the original problem. And then number 20, 64m to the fourth, that will be 8m to the second minus 9m squared, so plus 3n, and multiplied by 8m to the second minus 3n. So now for these last few problems, we have a bit of a challenge. In these problems, we need to look for a greatest common factor first. And after we pull out the greatest common factor, which was yesterday's lesson, then we can factor the remaining difference of squares. So if we pull out a greatest common factor, we hope we are left with a difference of squares. So number 21, we're going to factor out a 2, because that would leave us with n squared minus 36. So 2n squared minus 36. Now there's our difference of squares, the n squared minus 36. So we just keep the 2 factored out, and then we use the rule we've been doing. So it would be n plus 6, n minus 6. Okay, number 22, let's also factor out a 2, which would leave us with 9x squared minus 25, 2 perfect squares, so we can work with that. So that would be 2, and 9x squared would be 3x plus, and 25, that would be 5, and then 3x minus 5, and there's our final solution. Number 23, we're going to factor, again, we'll factor out a 2. That would leave us with 32 divided by 2 is 16, and we still have s squared minus 9u squared, and this is a difference of squares, so that works for us. So 16s2, that would be 4s plus 3u, not 9u. And multiplied by 4s minus 3u. And number 24, we're going to factor out a 5. When we factor out a 5, 45 divided by 5 is 9. Then we have that Q3 minus 20 divided by 5 is 4. In fact, we need to factor out the Q, so let's do that. I almost missed that. So we're going to factor out a 5 and a Q, because it won't be a difference of squares unless we do that. So this would be 9q squared, which is what we want, minus 4, because the q has already been factored out. And now we have a difference of squares, so 5q And this would be 3q plus 2, 3q minus 2. And number 25, now let's think about this. We want to end up with perfect squares here and here. So if we factor out a 2, that would give us 12. If we factor out a 4, that would give us a 6. But if we factored out a 6, that would give us a 4. So let's factor out the 6. If we factor out the 6 on the 54, that would give us a 9. So that's going to work for us. So 24 divided by 6 is 4, and we have that a squared. So perfect square there. Minus 54 divided by 6 is 9, and we have that b squared. So we have a difference of perfect squares. So let's rewrite. 4a squared would be 2a plus 9b squared would be 3b, and then 2a minus 3b, and then we're done. Our work is done. Number 26. So let's think about this. We don't have a square with the b. We do with the 100, and we do with the 36. However, if we factored 4 out of 136, we would end up with 25 and 9. So those are perfect squares, and they're smaller. So let's factor out a 4 and one of those b's, which would give us 25b squared minus 9, because we factored the b out. So now 4b, the 25b squared, that would be 5b, plus the square root of 9 is 3, and 5b minus the square root of 9, which is 3. So try these next few yourself. We got 6 more left. I'd love to see you try them yourself, and let's see how you do. So for number 27, we're certainly going to factor out an n squared. But I think let's also factor out a 5, because 80 divided by 5 is 16, and 100 divided by 5 is 25. So let's factor out a 5n squared. That leaves us with 16n squared minus 25. So we can work with both of these perfect squares. We have a difference of squares, 5n squared. And so this would be 4n plus 5, 4n minus 5. How did you do with that? Now, in number 28, we can factor out the 8, and we can also factor out this y, and that will give us y squared on the second term. So 8 comes out, y comes out. That gives us x squared minus 32 divided by 8 is 4, and y to the third divided by y is y squared. Now there's our difference of squares right there. So let's write our difference of squares. That would be x plus 2y multiplied by x minus 2y. And that's our final answer there. I'm going to get a darker color here. So for number 29, I think we could factor out the 9 and the p, because we want to get an even exponent here. So let's factor out the 9 and a p, which would give us 36 divided by 9 is 4. And then p to the third divided by p is p squared minus, and then we factored out 9p, so we have to put a 1 there. So perfect, we have a difference of squares, so it would be 9p, and then multiplied by 2p plus 1, 2p minus 1. And number 30, if we divide if we factored out the 3, let's think about this. If we divide 147 divided by 3, we have 49, which is a perfect square. So let's factor out the 3, but we'll leave the n squared in. So 3 comes out, so we have n squared minus 49, which is our difference of squares. That works for us. So now 3 times the quantity of n plus 7 and n minus 7, and our work is complete. For number 31, we need to factor out a k for sure, and let's factor out a 4. So then we can have a 4 here and a 25 here. So 4k comes out, which gives us 4k squared minus 25, because we factored the k out. So we do have a difference of squares. So we have 4k times the quantity of 2k plus 5 times the quantity of 2k minus 5 as our final answer. And then our last problem here, we have m to the third n minus mn, so we definitely need to factor out an m, but we can also factor out an n, so let's watch how this works. We're going to factor out m and n, which will give us m squared minus 1, because we factored out the m. So m squared minus 1, so that's our difference of squares. So we have mn, m plus 1, m minus 1. Final answer. So let's go back up to our exit ticket, which asks, what is the difference of squares rule? And the rule is a squared minus b squared equals a plus b, that quantity multiplied by the quantity of a minus b. So you'll notice at the end of this document, I have, let's look at it. This is all your hard work today. Your homework, 1 page, a little arts activity for you if you get bored later on today. We have a word search of April weather. I can start you off with rain showers. Let's get a nice blue for that. So here's our rain showers. And let's see what ones you can find. And then also you can check last night's homework, because I've put the answer key right there. So good job, everyone. I'm super proud of all your hard work. Make sure you have boots and an umbrella for those rainy days in April. They're sure to come. And remember, please do your homework tonight. You really need to get that practice, because as you get that practice and you work these things over and over again, you know what'll happen. Like it or not, you'll be great.